So once again, welcome all for the second session of the P block elements 2. So followed by the nitrogen and the family of the nitrogen ammonia, we are going to discuss with the nitric acid. Nitric acid is an excellent oxidizing agent and an excellent nitrating agent. We are all very well aware of it since we have come across various organic units also. See, how come nitric acid has been prepared? There are various methods of the preparation, out of which some of them have been given to us syllabus. The preparation includes by treating the potassium nitrate or sodium nitrate with the help of a sulfuric acid. So if the resultant product is the potassium hydrogen sulfate followed by the main product nitric acid. The nitric acid has an ability to decompose to form nitrite or nitrogen dioxide. So in order to prevent the decomposition of the nitric acid, the temperature has to be maintained as much as low as possible. Secondly, during the preparation of an acid, this is nitric acid has an ability to condense and forms a fuming brown colored liquid because of the decomposition which takes place for the formation of the nitrogen dioxide. Since the decomposition results in the formation of the nitrogen dioxide, the resultant nitric acid color changes to the brown color. So in order to avoid all these sort of the decomposition and to avoid the color changes during the preparation, the temperature has to be kept as much as low as possible. Let's look into the reaction. See, as I said, potassium nitrate reacts with sulfuric acid, potassium nitrate, which is KNO2, reacts with sulfuric acid to form potassium hydrogen sulfate plus nitric acid. So potassium nitrate with sulfuric acid gives potassium hydrogen sulfate with nitric acid. So we need to check with the balancing. So nitrogen 1, oxygen 7, so here it is 6. So we need to balance with it. See, so if I make it as 2 here, potassium becomes 2, sulfur becomes 2 here, so I will make it as 2 here. Then hydrogen becomes 4 there, so I need to make it as 2 here. So oxygen becomes 2, 8 plus 6 is 14, 8 plus 4 is 12. So again we need to multiply it like 3 here. Then potassium also becomes 3 here. Then followed by the hydrogen balancing, 3 plus 2 is 5. So here it is 4, we cannot balance it. So I have to double it the stoichiometry. So I will come from the beginning itself. See, potassium nitrate KNO3 reacts with H2SO4, gives KHSO4 plus HNO3. Okay, so this is how the reaction goes. And to balance with potassium 1 is here, then here also it is 1, hydrogen 2, okay, fine. Sulfur here it is 1, there it is 1. Oxygen 4, 4, 3, 7, everything is balanced. See, in this, initially I have wrote in terms of potassium nitrite, so that's why the equation took long time to get balanced. So actually reaction happens between the potassium nitrate and the sulfuric acid. Then followed by, see, the nitric acid preparation has to be done at a very low temperature. So nitric acid, if the reaction is not done in the low temperature, it results in the decomposition of nitrogen dioxide plus water plus oxygen. So to balance it, I will make it as 4 here. So I have to make it as 4. Hydrogen becomes 4. So I will make it as 2 here. We need to check with the oxygen. 12, 8, 8 plus 4, 10, 8 plus 4, 12. Balance. That's all. Okay. Right. So this is the very first method of the preparation of this nitric acid. The second method actually involves the commercial method. Commercial methods of preparation is the asphalt process. The ammonia that has been obtained from the Haber's process is mixed with the air in the ratio of 1:10 and passed through the chamber in order to prepare this nitric acid. See, this ammonia that has been passed into the chamber has to be preheated, which means it has to supply through hot. It has to go into the chamber with a hot condition. So that's what it means, the preheated. So the temperature has to be maintained at 1275 Kelvin and the whole ammonia and the air is being passed over the platinum gas. So the reaction takes place. Ammonia will react with an oxygen to form a nitric oxide. So NH3 reacts with oxygen to form nitric oxide NO, then H2O, then amount of energy that has been released here. So to balance with nitrogen, hydrogen here it is 3, there it is 2, so we cannot balance it, so we'll make it as 2. So nitrogen becomes 2 here, hydrogen becomes 6, so we'll make it as 6 here. Oxygen becomes 5 here, so 5 by 2 of O2. Or you can just double up the stoichiometry as 4 here, then 5 here, 4 here, or 6 here. In such a way you can do. Similarly, the nitric oxide that has been formed will react with the oxygen further to form nitrogen dioxide. So to balance it, 2 here, so I'll make it as 2 here. See, initially ammonia and air is being passed through the chamber in the ratio of 1:10 as a preheated condition. Temperature has to be maintained at 1275 Kelvin, and the whole mixture is further heated. That's why the temperature is maintained, and it has been passed over the platinum gas. Since ammonia and oxygen reacts to form a nitric oxide will react with the oxygen to form nitrogen dioxide. Then the third step includes the nitrogen dioxide reacts with the water to form the nitric acid. Nitrogen dioxide NO2 reacts with water molecule H2O to form nitric acid HNO3 with the evolution of NO. So to balance with, so hydrogen here it is 2, here it is 1, so I'll make it as 2 here. If I make this 2, nitrogen becomes 3, so I'll make it as 3 here. So oxygen, we need to check with the oxygen. Oxygen 6 plus 1 7, there also 6 plus 1 7, equation is balanced. See, from the industrial methods of the preparation, we are able to find that nitric acid that we have got will be very little bit dilute. So we need to concentrate it further and we need to supply it. So this is what happens in the commercial methods of the preparation of this nitric acid. Then the properties include, this pure nitric acid is colorless. Obviously, when it interacts with the atmosphere, it changes into the brown color due to the decomposition of the nitric acid to the nitrogen dioxide, which we have seen recently. See, the next one is, if the boiling point of this nitric acid is 86 degrees Celsius, and this acid is have ability to mix with the water. So that's why it is mentioned as a completely miscible with water, and it forms a boiling mixture, which means along with the water it exhibits as a mixture, and the boiling point of it is 120.5 degrees Celsius. So this is the boiling point of this 98% of pure nitric acid. 98% pure nitric acid. Then action of heat, the decomposition reaction which we have seen already. The nitric acid HNO3, on heating it decomposes to nitrogen dioxide NO2 plus H2O plus O2. So to balance with 4 here, so 4 here, hydrogen 4, so I'll make it as 2 here, so equation is balanced. So pure nitric acid, actually when the nitric acid is pure, it remains colorless in the beginning, slowly it converts into the yellow color. So that's why the pure nitric acid turns yellow if the decomposition doesn't take place. Suppose if the decomposition takes place, we may expect the formation of a brown color. The next one, reaction with an acid. See, this action of this nitric acid with the oxides of the metal forms a salt. Say for example, with the base or basic oxide, it forms a salt and water. So basic oxide, that all the metal oxides are base. So zinc oxide reacts with nitric acid to form zinc nitrate, Zn NO3 twice plus H2O. Zn NO3 twice plus H2O. So to balance with nitrogen, here it is 2. So if I make it as 2 here, fine, nitrogen is balanced. If you look into the oxygen here is 6 plus 1 7, 6 plus 1 7, balanced. Hydrogen here it is 2, there it is 2, equation is completely balanced. Then similarly, ferrous oxide FeO reacts with nitric acid in the ratio of 3:10. When it reacts with the nitric acid in the ratio of 3:10, the product is FeNO3 thrice, ferric nitrate. So iron here it is 3, so I'll make it as 3, nitric oxide NO plus H2O. So this is the expected reaction. So to balance with iron 3, fine, nitrogen 10, here it is 9, there it is 10, hydrogen we need to check 10 here, so I'll make it as 5 H2O here. So equation is completely balanced. The next one, reaction of the reaction with the non-metals like a carbon to show that nitric acid has an ability to oxidize the other substances in which it is reacting with it. See, carbon reacts with nitric acid to form water molecule, nitrogen dioxide and carbon dioxide. So main product nitrogen dioxide. So we need to check with the balancing. So hydrogen here it is 2. If I make it as 2, nitrogen becomes 2. So I need to make it as 2 here. Then we need to check with the oxygen. Oxygen here it is 6. Then 4 plus 2, 6, 6 plus 1, 7. There it is 7. If I make it as 4 here, let me check. If I make it as 4, nitrogen becomes 4. So I will make it as 4 here. Then carbon will take up oxygen and goes as carbon dioxide. Hydrogen here it is 2. So I will make it as 2. Here it is 4. So oxygen 12, 2 plus 8, 10, 10 plus 2, 12. Equation is completely balanced. Okay. The next one is regarding the other reactions with the nitric acid to show that it is an excellent oxidizing agent. Very first, sulfur reacts with the nitric acid to form the sulfuric acid. Let's check. Sulfur reacts with the nitric acid to form sulfuric acid along with nitric oxide. So to balance with, so hydrogen here it is 2. So I need to make it as 2. Okay. Sulfur 1, nitrogen 2. So I need to make it as 2 here. Oxygen 6, 4 plus 2, 6. Equation is balanced. Next one. Phosphorus reacts with nitric acid in the ratio of 1:20. You need to have it in mind because stoichiometry will take almost 15-20 minutes to complete for you people all. See, phosphoric acid is H3PO4. So phosphorus there is 4, here it is 4. So water molecule is H2O, then nitrogen dioxide NO2. We need to check the nitrogen. Nitrogen here it is 20. Then if I make it as 20, equation is balanced. Hydrogen we need to check. Hydrogen 20 here 12. If I make it as 4 here, equation balanced. That's all. Right. Next one. Iodine. Iodine reacts with the nitric acid to form iodic acid, then nitric oxide, then water molecule. So we need to check with the balancing. Iodine here it is 2, so I will make it as 2 here. Iodine is fine. Hydrogen here it is 2 plus 2, 4. If I make it as 2 here, oxygen becomes 6. 6 plus 1, 7. Then here it becomes 2. Hydrogen becomes fine. Okay, 6 plus 4 is 6 plus 3 is 9 there. Here it is 6. Then I need to make it as 3 here. If I make it as 3, it forms hydrogen 3 here. I cannot make it as 3. If I make it as 6 here, if I make it as 6, if I make it as 6 here, HNO3 forms NO plus H2O. See, this is called iodic acid or hydroiodic acid. Also, you can say HiO3. This is the one you can say. See, then if I make it as, if I double the stoichiometry, iodine, if I make it as 2 here, hydrogen becomes 4. Hydrogen, when hydrogen becomes 4, I need to make it as 4 here. Then if I, let me just check, 2 here, hydrogen 4, so I will make it as 4. Nitrogen becomes 4 here. Here it is 4. I need to check with the oxygen 12. 6 plus 4, 10. 10 plus 2, 12. So to balance with the hydrogen, if I make it as 2, that's all. Okay. Right. So this is regarding the reaction with the nitric acid. Then the next one is fluorine reacts with nitric acid and forms hydrofluoric acid HF and fluorine nitrate NO3F or FNO3. See, that's all. Just the one of the hydrogen will take up the fluorine and goes as HF. Then one of the fluorine will combine with the NO3 and goes as a NO3F. Then hydrogen sulfide H2S reacts with nitric acid to form sulfur, then nitric oxide, then water. So balancing. So hydrogen 2, there it is 2. Sulfur here it is 1, there it is 1. Nitrogen 1, 1. Oxygen 3, there also here, there it is 2. Right. So then I need to multiply it. 2 here, there it is. So hydrogen, there it is, here it is 3, there it is 2. If I multiply it by 2, hydrogen becomes 4. So if I make it as 2, that's all. Hydrogen is fine. Hydrogen becomes 4 here. Then I need to check with the nitrogen. Nitrogen here it is 2. Then hydrogen totally, oxygen there it is totally 6. But here it is, there it is 4, here it is totally 6. So I need to multiply with this here. So instead multiplying there, I will multiply here. H2S reacts with HNO3 to form sulfur plus nitric oxide plus water. If I make it as 2 here, hydrogen becomes 4, okay, sulfur becomes 2, okay, nitrogen becomes 1, okay, hydrogen here it is 5, there it is 4. So no other go, I have to multiply it further. If I multiply it likewise, so hydrogen becomes 6, so I will make it as 3 here. So nitrogen becomes 2, so I will make it as 2 here. So there it is 6, there it is 4. Then I need to double the stoichiometry, no other go, because here it is 6 oxygen, there it is 5 oxygen. The only thing that I can do is I can multiply it further. Hydrogen, if I make it as 4H2O here, if I make it as 4H2O, hydrogen becomes 8. So here, if I make it 3 here, hydrogen becomes 8 here. There, because 3 2s are 6, 6 plus 2 is 8. Sulfur here it is 3, so I will make it as 3. Oxygen 6, 4 plus 2 6. Equation is balanced. The next one, benzene has a ability to nitrate the organic substance like benzene. Now, nitric acid has an ability to nitrate the organic substance like a benzene to form a nitrobenzene. See, benzene C6H6 with HNO3. HNO3 I will make it as HONO2 with the help of a sulfuric acid. Sulfuric acid along with the nitric acid act as a nitrating mixture. Then one of the hydrogen will take up this OH and goes as H2O. Your product is C6H5NO2. So this reaction proceeds by the formation of the nitronium ion with the help of a sulfuric acid. Let's check. HONO2 nitric acid plus H2SO4 forms. This NO2 comes out as NO2 plus. This H and OH will goes as H2O. Then one which is left out is HSO4 minus. This nitration takes place with the help of sulfuric acid because the formation of the nitronium ion being done by the sulfuric acid. That's the reason. Next one. Action of nitric acid with the metals. See, mostly nitric acid will not react with the noble metals like platinum, gold, etc. Iridium, rhodium and tantalum, all these metals. But it has a tendency to oxidize certain metals like magnesium, zinc, then we have got copper, like these kinds of the metal gets oxidized easily by the nitric acid. There are certain metals like aluminium, chromium, etc. They can be oxidized by the nitric acid, but during oxidation, the very first layer forms the oxide. Once it forms an oxide, it will not react with the nitric acid directly. Instead, it will react passively. Which of this metal? Like aluminium, chromium, etc. These kinds of the metal, because in the beginning it will react with the nitric acid so easily and gets oxidized to the oxide form. Further, when the nitric acid reacts with those metals, it will not react. It will react only passively. Okay, so that's the information regarding the action of the metals. Then, looking into the reaction, see, this nitric acid, when reacts with the metal, it produces the nascent hydrogen. Okay, this nascent hydrogen actually turns the nitric acid into various products, byproducts: nitrous acid, hydroxylamine, ammonia, hydronitrous acid. See, it depends on the metal to which it is reacting, the byproducts that you may expect. So this page has been displayed just to show that what kind of a byproduct that nitric acid can produce when it reacts with a metal. See, when this nascent hydrogen is being produced when the nitric acid reacts with the metal, obviously it forms a salt, right? So this nascent hydrogen produces nitric acid, nitrous acid, hydroxylamine, ammonia, hydronitrous acid, etc. This is secondary reaction during the reaction happens with the metal. Then tertiary reaction, suppose if our byproduct, one of the intermediate product is nitrous acid will oxidize to nitric acid and the nitric oxide. Similarly, nitrous acid can also be changed into dinitrogen trioxide or nitrogen trioxide. Hydronitrous acid can be changed into nitrous oxide. So, all the byproduct that has been formed during the second reaction can further change into the tertiary products. So this is reaction. See, among the nitric acid and the product that has been formed can react with each other. Say for example, the nitrous acid has an ability to react with ammonia. Nitrous acid has an ability to react with the hydroxylamine. Nitrous acid has an ability to react with the nitric acid also. So such kinds of reactions also can be expected. So similarly, which you are looking into it. Nitrous acid reacts with ammonia. Nitrous acid reacts with hydroxylamine. Nitrous acid reacts with nitric acid. So various byproducts will be formed during the reaction which takes place with the metal and the nitric acid. So this is regarding the content that you must know what kind of a possible byproduct that we could expect during the reaction between the metal. Very firstly, the reaction with copper is given. The reaction with copper includes actually the reaction with copper actually includes the dilute nitric acid. Copper reacts with nitric acid to form copper nitrate, nitric oxide plus water. So this is the reaction. The reaction goes like copper reacts 3 times. So here it is 3. So I have to make the nitrogen to get balanced with. I have to put an even number. No other go here. So nitrogen here it is 3. 2 3s are 6 nitrogen. There it is 2. Suppose if I make it as 8 here, nitrogen, if I make it as 2, nitrogen becomes 8. We need to check with the hydrogen. Hydrogen 8, you can easily make it as, by making it as 4. Oxygen 24 here, 6 3s are 18, 20, 24. Equation is balanced. So reacts in the ratio of 3:8 condition here. Then the next one. The next reaction includes reaction with the concentrated nitric acid. Reaction with the concentrated nitric acid gives the byproduct as nitrogen dioxide. See, copper reacts with the nitric acid to form copper nitrate, CuNO3 plus nitrogen dioxide plus water. So we need to check with the balance here. See, if we check with the balance here, hydrogen there it is 4. Suppose if I make it as 4 here, hydrogen makes 4 here. Nitrogen, if I make it as 2 here, it becomes 2, not here. So copper reacts with nitric acid to form copper nitrate plus nitrogen dioxide plus water. So this is the byproduct that we could expect. Okay. Then so if I make it as 1:4 ratio, if I make it as 4, nitrogen becomes 4, so I need to make it as 2. Hydrogen I need to make it as 2 here. So oxygen 12, 6, 10, 12. Equation is balanced. Then regarding magnesium, both in the dilute condition and the concentrated condition reacts in the ratio of 4:10. See, magnesium reacts with nitric acid, forms magnesium nitrate plus nitrous oxide plus water. So balance with hydrogen here it is 10, so I will need to make it as 5 here. Magnesium 4, if I make it as 4, nitrogen is 8, balanced. We need to make it as 2 here, it is balanced. Oxygen 30, 3 2s are 6, 6 4s are 24, 24 plus 5 29, 30. Equation is balanced. Similarly, magnesium with the concentrated nitric acid also reacts in the ratio of 4:10. If it reacts in the ratio of 4:10, your product is magnesium nitrate, then ammonium nitrate, NH4NO3 plus H2. So here also, if we make it as 4, here it is balanced. Hydrogen we need to check 10 here. If I make reaction with magnesium. includes both the nitric acid and the dilute nitric acid and the concentrated nitric acid. Let's check. See, zinc reacts with the dilute nitric acid to form zinc nitrate plus nitrous oxide plus H2. Then here also zinc reacts with the nitric acid to form zinc nitrate plus nitrogen dioxide plus water. See, here with the dilute nitric acid, assume that zinc reacts. So your product is 3. So nitrogen you need to check. Nitrogen, if you take 6 plus 2, 8. If I make it 8 here, hydrogen becomes 8. So I need to make it as 4. Oxygen 24. 3 2s are 6, 6 3s are 18. 18 plus 4. 22, 22 plus 1 is 23. So 1 is pending there. So that's all. You need to sum up, bring it up so that you can able to balance. So here reaction takes place like, suppose if I may, let me just check. If the reaction takes place in the ratio of 4:10 as we have seen in magnesium, let us check. So zinc with nitric acid, Zn NO3 twice plus N2O plus H2O. Zinc reacts with concentrated nitric acid, gives zinc nitrate plus nitrogen dioxide plus water. So if the reaction is taking place in the ratio of 4:10, zinc becomes 4 here, nitrogen becomes 8, 8 plus 1, 9. So I cannot double up. See, if I make the stoichiometry here, it has 4:10. Zinc becomes 4 here. Nitrogen is already balanced 10. Hydrogen here it is 10. So I make it as 5. If we check with the oxygen, then things would be fine. If you check the oxygen, 6, 3 2s are 6, 6 4s are 24. 24 plus 6 is 30. The equation is balanced. This is fine. So this one, you need to check. It is not in the ratio of 4:10. Instead, zinc reacts with the concentrated nitric acid, zinc nitrate plus nitrogen dioxide plus water. So nitrogen here it becomes as 2 here, 2 plus 1 3. If I make it as 3, I cannot balance this hydrogen. So what I can do, if I make it as 6 here, hydrogen can be balanced by balancing it as 2. Nitrogen, if you balance it, say for example, if the reaction is taking place here, it is 3, so I will make it as 3 here. Nitrogen becomes 6, 6 plus 1 7, 7 is not possible. I can make it as 8, so that I can make it as 8 here. So hydrogen becomes 4, 8 there, so I will make it as 4 here. Check with the oxygen, 24, 6, 6 3s are 18, 18 plus 6 24. Equation is balanced. That's all. Okay, only the thing is you need to check. It takes time to balance. That's the only thing. Instead of having balancing in the exam duration, you can just have it, the stoichiometries in mind, at least in the left hand side. If you know the left hand side stoichiometry, right hand side it is easy to balance. That's it. Then uses of nitric acid. Nitric acid is used as an excellent oxidizing agent, and it is also used in the preparation of an aqua regia. Aqua regia, it is the combination of an HCl and the nitric acid. Then silver nitrate is widely used in the photography. Then sodium nitrate is used as a gunpowder in the firearms. So this is regarding nitric acid. Then oxides of the nitrogen. Oxides of the nitrogen includes various oxides, out of which some are given. Nitrous oxide N2O, the oxidation state of the nitrogen is +1 and it's a colorless neutral gas. When ammonium nitrate is decomposed, NH4 NO3, when it decomposed, it forms nitrous oxide N2O plus H2O. So I hope the equation is balanced. If it is not, so if I make it as 2, equation would have been balanced. That's all. Then nitric oxide. Nitric oxide has the formula NO, and the oxidation state of nitrogen is +2. It's a colorless neutral gas. Then sodium nitrate NaNO2 reacts with ferrous sulfate FeSO4 plus sulfuric acid gives ferric sulfate Fe2SO4 thrice. Then sodium hydrogen sulfate NaHSO4 plus H2O plus NO. So these are all the byproducts that you may able to expect here. Okay, right. So need not to be balanced further, I guess. So 2 here, if I make it as 2, then it is fine. Sulfur becomes 3 here, also it is, sulfur becomes 4 here. So here it is 3, only 3. I need to check with the sodium and nitrogen, etc. Nitrogen, here it is 1, there it is 1, sodium 1, fine. Hydrogen 3, 2 plus 1, 3. I cannot have this number in terms of a even number, so I'll make it as 2. I'll make it as 2 here. So sodium becomes 2, nitrogen becomes 2 here. Then oxygen becomes okay, fine. Sulfur, okay. Hydrogen 4, so I need to make it as 2. So sulfur is also fine. Hydrogen I need to check. Hydrogen 4, oxygen 4 plus 8, 12, 12 plus 8, 20. Here it is 12 plus 4, yeah, almost balanced. So this is regarding the nitric oxide preparation. The next one includes the nitrogen dioxide, which is called sesquio oxide. Otherwise we can say N2O3. The oxidation state of the nitrogen over there is +3. It's a blue solid and acidic. So nitric oxide reacts with dinitrogen tetroxide N2O4 to form N2O3, dinitrogen trioxide. So balance with, if I make it as 2 here, it becomes 4. So I need to make it as 2 here. So oxygen becomes 6, here also it is 6. So balanced. The next one, dinitrogen dioxide, or you can say nitrogen dioxide NO2. See, lead nitrate PbNO3 twice will convert it into lead oxide by evolving nitrogen dioxide and molecular oxygen. So balancing nitrogen 2, so here it is 2, oxygen 6, 4, 6, here it is 7. So if I make it as 2 here, lead becomes 2, nitrogen becomes 2, nitrogen becomes 4, then oxygen is 3 2s are 6, 6 2s are 12, 8 plus 4, 12, balanced, that's all. Then nitrogen tetroxide N2O4 has the oxidation state of +4, colorless solid, acidic in nature. So the decomposition reaction of the combination reaction of NO2 nitrogen dioxide, 2 molecules will result in the formation of N2O4. Then nitrogen pentoxide, nitric acid reacts with phosphorus pentoxide P2O5 to form dinitrogen pentoxide N2O5, metaphosphoric acid HPO3. So this is metaphosphoric acid. The oxidation state of the nitrogen here is +5. It's a colorless solid and acidic in condition. So let's balance. So phosphorus 2, so here it is 2, nitrogen 2, so I'll make it as 2, hydrogen becomes 2, there also it is 2, oxygen we need to check, 6, 6 plus 5, 11, 5 plus 6, 11, equation is balanced. Then the next one includes the structure of these oxides of a nitrogen. The structure of an oxides of the nitrogen includes the hyponitrous acid. So silver hyponitrite, which is Ag2, N2O2 plus HCl, it forms AgCl. 2 molecules of Ag will take 2 molecules of Cl and goes as HCl. Hydrogen will replace this. So it becomes as H2N2O2. So this is your hyponitrous acid. Then next one, the structure. Structure includes like, I hope you are all aware of the Lewis acid structure. So skeleton you need to know. So this is the structure of H2N2O2, and after which you need to place the lone pair of an electron over oxygen, 2 lone pairs, nitrogen, a lone pairs. over nitrogen there is a lone pair, that's all. Over oxygen there is a lone pair. So having mind with the Lewis dot structure, you can able to plot. Then hydronitrous acid H4N2O4. N double bond N will have 2 OH. You have to keep in mind with the skeleton. If the skeleton is known, it is easy to plot. The next one, nitrous acid. Nitrous acid preparation is barium nitride, BaNO2 twice plus H2SO4 gives BaSO4 plus 2 molecules of HNO2. So this is regarding nitrous acid. The structure of the nitrous acid will include, it is HON double bond O. Two lone pairs, 2 lone pairs, 1 lone pair. So this is the structure of nitrous acid. The next one, pernitrous acid. Pernitrous acid, you have to take this hydrogen peroxide H2O2 reacts with nitrous acid HNO2 gives pernitrous acid, which is HOONO plus H2O. So balancing we need to check. Hydrogen 3, here it is 3, oxygen 4, nitrogen 1. Equation is balanced. The structure includes HOON double bond O. So lone pairs, lone pairs, lone pairs, lone pairs, lone pairs. So this is the structure of this pernitrous acid. The last one includes the nitric acid. Nitric acid has been prepared dinitrogen tetroxide, which is N2O4 reacts with H2O plus O2 forms HNO3. So we need to balance with nitrogen, there it is 2. If I make it as 2, okay, hydrogen is 2, oxygen is 6 plus 1, 7, it turns as 7. So if I make it as half, then it is fine, or else you need to double the stoichiometry. If you double the stoichiometry, it turns, here it turns 2, here it is turns 2, here it is just 1, here it is 4. So equation will be balanced. Then structure of this nitric acid includes HONO2. Okay, so this is what the structure of the nitric acid will include. Okay, so 2 lone pairs, lone pairs. So this can be a structure of this nitric acid. Then pernitric acid. Pernitric acid has a molecular formula HNO4. The oxidation state is +5. The structure includes HOONO2. So lone pairs, lone pairs, lone pairs, lone pairs, lone pairs, lone pairs, lone pairs. So this is regarding the structure of this oxides of nitrogen. See, this content that we have seen today, actually it's a very big content, nitric acid, and followed by the structure of the nitric acid, out of which the expected questions might be very, very less. But the thing is, you should not go without studying or without knowing what is present in this content. You may expect a 1 mark questions, what might be the byproduct that nitric acid can produce on treatment with the metal. We may expect nitrous acid, we may expect ammonia, we may expect hydroxylamine, we may expect hydronitrous acid. And what happens when the ammonia reacts with the nitrous acid, or nitric acid reacts with the nitrous acid? What is the byproduct? Those are all things we have to keep it in mind. And while balancing the equation with the metals, you have to it is better to keep in mind with the stoichiometry instead spending lots of time in balancing. So this is my suggestion for you all, to go with the content as like this. So here in today's content, we'll continue with the phosphorus and its elements and its compounds and the structures of the phosphorus and the allotropes of the phosphorus in the next session. Thank you. See you all in the next class.